Right guys, so this is question 2 of the 2018 June paper. So it says electrolysis of brine can be carried out in a membrane cell. Like I've said before guys, they always tend to ask about brine. In the June 2022 paper, there was a question indirectly referred to brine as well. And I'll come back to that question in a second, but yeah, here we've got figure 1, which shows a membrane cell. Okay, so there are 3 products of the electrolysis of brine. It's chlorine and hydrogen. They always come out from the top because they're gases, so they are less dense, so they're just collected from the top. And there's also sodium hydroxide as well. So sodium hydroxide, chlorine and hydrogen are the 3 products of the electrolysis of brine. And if you remember, brine is basically sodium chloride in water. So that's why we are inserting concentrated sodium chloride solution in to the whole electrolysis setup. And then by the end of the electrolysis, we collect chlorine, hydrogen, and also, as you can see here at the bottom, sodium sorry, not on the bottom here, but on this side, sodium hydroxide solution is collected. Okay, so we insert sodium chloride, which is brine, sodium chloride solution, that's brine. We'll collect chlorine and hydrogen from here. Those are 2 products, and also the 3rd product, sodium hydroxide, is collected on the other side. Okay, sodium hydroxide is always collected from the opposite side of where sodium chloride is inserted from. Okay, now it says that the cathode hydrogen ions gain electrons to produce hydrogen gas. You can see that here. So cathodes are negatively charged electrodes. This is a cathode. They attract cations. Cations are positive. Okay, so they attract those cations. That's why they are cathodes. These electrodes are cathodes. So yes, near the at the cathode, hydrogen is produced. This is the half equation. Okay, now it says at the anode, chloride ions lose electrons to produce chlorine gas. That's what's happening here. We've got the anode. Anodes attract anions, which are anions are negatively charged, so they're attracted to the oppositely charged anodes, which are positively charged. So the chloride ions will lose electrons to make chlorine. Okay, so it says write a balanced half equation for the production of chlorine at the anode. So half equation, so if you ever see that the word phrase half equation, that means that you need to show either electrons being added or taken away. Okay, so it's going to so it should say plus E minus or minus E minus. Okay, so let's just have a look at the mark scheme. So this is what it would look like. Let's just scroll down. Now, it was question 2, right? Oh no, this is the 2022 paper. Let's just get up the 2018 paper. Sorry, I was just looking at something else. Sorry guys, let's just bring this up. Yeah, so this is what it would look like. Okay, so we've got a chloride ion. That chloride ion, as you can see, is negatively charged. Okay, so if we're losing electrons, it becomes Cl2 plus 2E minus. Okay, I don't like writing it this way. In an exam, you might come across this equation, and that means that it's losing electrons. Okay, because it's negative here and it's becoming neutral, that means that it's losing electrons. If it's losing electrons, we need to show that the electrons are being lost, and by showing it at the end. But I prefer writing it like this, and I'll just show you. So I prefer writing it as this. So you start off with a chloride ion, and then you're taking away 2 electrons to make Cl2. Okay. Because essentially, to me, this is showing oxidation because we're losing 2 electrons. But it's really important that you recognize equations which look like this as well. So 2Cl minus, just ignore that. Cl2 plus 2E minus, okay? Both of these equations mean the same thing, okay? I just prefer this because that shows that 2 electrons are being lost. I mean, this one also shows the same, but, you know, as long as you understand both, that's fine. Because in an exam, they could show you an equation that looks like this or like this, and you need to understand both of those are oxidations, okay? That's why it says allow this, which is what I just showed you. Now, if we look at the next question, now I really like this question, and I want you all to listen to what I'm saying for this question, okay? Because I've seen questions like this come up quite often, or questions similar to this. So it says, explain the function of the membrane in the cell shown in figure 1. So in the electrolysis of brine, there's always a membrane down the middle, okay? And you need to understand the function of this membrane. And I'm going to just show you the mark scheme, okay? So you need to say that the membrane keeps the chlorine gas separate from the hydrogen gas, okay? So that's the first thing, because we are trying to collect chlorine and hydrogen, okay? So we need to keep them separate. And you need to also say that chlorine will not be able to react with the sodium hydroxide, okay? Because chlorine is actually acidic in nature. So, and sodium hydroxide is alkali, okay? So there's a chance that they will react together if we don't keep them separate. So if we just have a look at this membrane, okay? Chlorine is being produced there, and we have sodium hydroxide. If we don't, sodium hydroxide is obviously produced on this side, sorry, okay? And chlorine is basically, is produced here, okay? And we've got a barrier down the middle. If sodium hydroxide is here and chlorine was also being collected on this side, there's a chance that the chlorine will react with the sodium hydroxide, and that's not good, okay? Because at the end of this, we need to collect chlorine and sodium hydroxide separately. Also, membrane allows Na plus ions to pass through, okay, and it does not allow Cl minus ions to pass through. So you get 2 different marks for saying that. So the membrane allows positive ions, make sure you to pass through. Make sure you remember that. You get 1 mark for saying that, or for saying that it does not allow negative ions to pass through. So if we have a look at this, positive ions, so Na plus is being, sodium chloride solution is being inserted from here, okay? So anything that's positively charged, okay, what would happen is they will travel through the membrane and they will be attracted to the negative electrode, which is the cathode, okay? That's because anything positive will be attracted to the negative cathode, therefore it will go through the membrane. However, anything that's negatively charged will just stay there. It will be attracted to the anode, not the cathode, so it wouldn't actually go through the membrane. Okay, so that's why positively charged ions will go through the membrane, whereas negatively charged ions will not go through the membrane. Okay, also you can say that the sodium hydroxide solution is not contaminated with the chloride ions, which we mentioned before as well, and that this gives sodium hydroxide solution that is of higher purity or has fewer impurities. Okay, so those are the points that you can mention for that question. I really like this question because there was, let's have a look at the 2022 paper. Now, I'm just going to show you the 2022 paper. So there was this question. It says, the electrolysis of sodium chloride solution, brine, uses a membrane cell. Explain why membrane cell is not needed in the electrolysis of aluminium oxide. Okay, so this is the electrolysis of aluminium oxide. The setup is obviously quite different to brine. Okay, so now let's just have a look at the mark scheme. So this is 1C. I got it. So the reason why we don't need a membrane cell in in the extraction of in the electrolysis of aluminium oxide, we don't need to keep but what happens is the aluminium sinks to the bottom and oxygen goes to the top because of the difference in density. Oxygen is a gas, so it goes to the top, whereas aluminium goes to the bottom. A membrane is always used to keep the products separate, okay? Make sure you remember that. That's why we need this in brine solution, because there's a chance of everything mixing, okay? Whereas in the electrolysis of aluminium oxide, aluminium sinks to the bottom because of its high density, whereas oxygen goes to the top because of its lower density, okay? So you need to understand the purpose of the membrane. The main purpose is to keep it separate, but you need to understand how it keeps it separate and how all of the products, chlorine, hydrogen, and sodium hydroxide, are kept separate, okay?